Hello and welcome to my talk on the electric and magnetic forces. The electric and magnetic fields are both components of an electromagnetic field. First, let's look at an electric force. These are forces affected objects that have charge. So, charge is determined by the number of electrons and protons in an object. Equal number of electrons and protons in an object create a neutrally charged object. Electric forces. An electric field is directed away from a positive source and toward a negative source. Some combination of charges attract, which are opposite charges, and other repel, similar charges. So, the strength of an electric field is decreased when distance increases between charges.
On the left side of this, there is an electric field that you can't see. It's invisible. And to figure out where it is, we're going to use a positive test charge. We're going to put a positive charge there. We're just going to simply let it go. And I'll mark its original location. Watch what happens. Well, it's accelerating away. That means it must be experiencing a net force. We call that an electric force that's being created by a charge inside this field. So let's move that test charge somewhere else. See it's accelerating away a little bit more quickly. Now let's put it right here. So it really accelerated quickly. That means that there must be a charge somewhere around here, and it's a positive charge because it's pushing that positive test charge away. And so we could represent that field with these field lines. It's a vector electric field. And if you put any object inside an electric field, it's going to experience an electric force, and that's going to cause an acceleration in the opposite direction if it's a positive charge, and towards that charge if it's a negative charge. So you should be able to understand how an electric field is set up. We've got a positive charge in the center. The field lines are going to move away from that. And by convention, if it's a negative charge on the inside, the field lines are all going to point towards it. But we could have two plates that both.
Alrighty. So from this, there are two kinds of electric charges. First, we look at the stationary electric charge or static electricity. And then we also have the moving electric charge, aka an electric current. So, the product of a static electricity are electric forces, whereas the product of an electric current is electric and magnetic forces. So, static electricity is the accumulation of electric charges on the surface of an object. Where does it come from? The result of a constant contact with materials that can lose or gain electrons and create opposite charges. So, a fun fact: static electricity increases in dry conditions and decreases in humid conditions. So, moving electric charge or an electric current is a magnetic field exerts force on a charged particle only if that particle is moving. Another fun fact: electric currents can produce a magnetic field, meaning that an electric current can produce both an electric field and a magnetic field. So, the magnetic force is an attraction or repulsion that arises between electrically charged particles because of their motion. So, magnets, what are they? An object with a north and south pole that produces a magnetic field. They result from the spinning of electrons in a material. All electrons spin. The spinning of electron creates a tiny magnetic field with a north and south pole. So, the magnetic force, just as charges, particles are surrounded by electric fields, all magnets are surrounded by a magnetic field. So, the magnetic field flows out of the north pole of a magnet and into the south pole. Magnetic fields exert forces on other magnets. Also, magnetic fields exert forces on moving charged particles. So, here are some examples of how the current moves from the north to the south pole and back and forth. So as a rule, like poles repel each other and opposite poles attract each other. So as you can see, the North Pole is attracted to the South Pole, yet where you see that both the two South Poles are repelled by each other. And that's all, folks.